welcome to IMS GATE Academy Foundation course on Network Theory subject. So this is the fourth session regarding Network Theory subject regarding Foundation course. Whoever missed the earlier sessions, so all of you kindly watch those sessions in your free time. So all of you can visit our website IMS GATE Academy in the YouTube channel. Okay, and then just check the playlist regarding the Foundation course. After that you can see the playlist regarding Network Theory subject. So from there you can watch the previous lectures. Okay, due to any reason if you miss the earlier lectures, no issue at all of you can watch the previous lectures in your free time. Okay, so whoever watching or whoever visiting our YouTube channel very first time, so all of you kindly click on the subscribe button, okay, and share this video link with all of your friends so that they also will get benefited from this particular session. Okay, right. So before going to start today's session, I am going to give two important updates. After that we will start today's session. Okay, so this is the first important update regarding our Telegram channel. So IMS GATE Academy Telegram channel, regarding this particular link already provided in the description of this particular video, right? So whoever not yet joined till now, so all of you kindly join our Telegram channel. Whenever, like say for example, currently Network Theory subject GATE Foundation course lecture is happening in the live session at our IMS GATE Academy YouTube channel, right? So similarly, whenever upcoming live sessions are there, you will get the updates in this particular Telegram channel, and whatever the faculty might have written during the class, during the live session, right after the class over, this particular notes we will be sharing in the PDF form. That PDF we will be sharing in this particular Telegram channel. Okay, and you will be getting the important updates regarding webinar and the job notifications. Okay, and then on daily basis our faculty will post one quiz question on daily basis, so all of you can actively participate and you can check your confidence and knowledge. Okay, and the very next day our faculty will provide the solution for the previous day quiz question. In that way you are getting one opportunity, on daily basis you are learning something new. Okay, so these are all the benefits you are going to get. It is free for everyone. All of you kindly join our Telegram channel, whoever not yet joined. Okay, right. And then one more important update. Okay, so here at our IMS GATE Academy we are having the live online program. Whoever targeting for the upcoming GATE exams like in 2025 or 2026, right? So all the students, whoever aspiring to get very good rank in the coming GATE exams, right? So all of you kindly contact to any of these two numbers. Our counselors will discuss in detail about regarding live online program. For the time being, I will discuss the program features in brief. Okay, whoever enrolling for live online program, each and every student will be getting 800 plus hours of live online classes. During the live classes, each and every faculty of our IMS GATE Academy will discuss the concepts from very basic level to the application level. And not only that, we will be discussing variety of questions, practice questions and GATE questions as well during the class, so that you will get all the regarding those concepts, whatever you are learning during the classes, in order to get good command over those concepts and in order to know the good number of methods of solving and shortcuts, etc. All those, like whatever the practice questions and GATE questions our faculties will discuss during the classes will be helpful a lot. Okay, and in addition to that, for all our enrolled students, for every subject we are providing the theory book and we are providing the exercise book, right? All the exercise books related to your branch. Okay, together you will be having 4,000 plus practice questions, right? So here in our exercise book you will be finding like 3 levels of questions, like level 1, level 2, level 3, right? So all together, like the exercise books related to your respective branch, together you are having 4,000 plus practice questions. Whoever practicing these questions, it is you all the people will get good command over the concepts whatever you might have learned during the classes, right? And in addition to that, we are providing GATE question bank, and in this GATE question bank you will be finding the previous 34 years GATE questions along with the solutions, right? This is one of the special book at our IMS GATE Academy. Whoever enrolling for live online program, they will be getting 34 plus years GATE question bank, right? Here wherever required, our faculties have provided the more than one possible solution as well. And even for typical questions, our faculties have done the video solution, okay, regarding that particular video solution, you will be finding the QR code in the solution part. Just you have to open the QR scanner in your mobile and just scan that QR code, then the respective video solution video will be played. Okay, in this way you will be getting great learning experience while you are solving the GATE question bank. Okay, right. And in addition to that, we are providing together 130 plus various tests, right? So all these tests available in the LMS portal. Whoever registering for our live online program, all the students will be getting 130 plus online tests. You will be having for every chapter one test will be there, and similarly for every subject, basic level test will be there, advanced level test, advanced subject test will be there, and then even multi-subject test will be there, right? So after that, we are having all new mock tests as well, right? Whoever attending our classes and then practicing exercise book questions and then GATE question bank, right? After that, whoever practicing or attempting our online tests, all the each and every student, okay, they can get the confidence, they can check their confidence level, and they can check how to effectively utilize the given time, okay, especially whenever you are attempting any test. And in fact, whatever the silly mistakes you might be doing, you can overcome, and you will be coming to know how I can solve the given question in less time. Okay, in that way you are getting the opportunity to know multiple shortcut methods, right? So all these things will play a vital role in order to get very good rank in the coming GATE exam. Okay, and in addition to that, here at our IMS GATE Academy, we are providing 12 My Plan sessions for every enrolled student. Okay, right? So on an average, each and every month, right? So every student can book one My Plan session with the corresponding mentor, and they can get the proper guidance and study plan in order to get very good rank in the upcoming GATE exam, right? So these are all benefits. Okay, whoever enrolling for our live online program, they are able to get all these features. So now it's your time. You can contact to any of these two numbers and try to enroll as early as possible. Okay, right. So I hope all of you are eagerly waiting for today's session. So let us start. Yeah, in the last class we have discussed regarding resistors, series connection, parallel connection, regarding the formulas we have discussed, and then we have discussed variety of GATE questions based on series and parallel, right? So whoever missed the last class, so all of you kindly check and watch that particular session, and all of you give a try before watching the explanation of each and every question, right? So with the help of, if you know the series connection formula regarding resistors and similarly parallel connection formula regarding resistors, with the help of that, how easily we can attempt the GATE questions regarding that. Whoever want to check the confidence based on resistors, equivalent circuits based on series and parallel. Okay, in this particular session, let us move on to the next passive element, that is inductor. Okay, so in this particular session, let us focus the remaining two passive elements like inductor and capacitor, and we'll discuss all the formulas related to inductor and capacitor, and then we'll discuss based on the possibility, we'll discuss few example questions as well. Okay, right. So here inductor is nothing but whatever the conductor you're having, like one single wire, whatever you're having, that is a conductor. Okay, if that particular wire is allowing the current, so then we will call that particular material as conductor. Then whatever the straight conductor you're having, that one we are making n number of rounds like this. Okay, so then that particular conductor only we are calling it as inductor. Okay, right. So now what will happen, suppose if you are passing current, okay, through this particular coil, okay, and that current is a time varying current, then because of that what it will produce? Any guess? All of you read this sentence and can you answer this particular sentence? All of you give a try. Yeah, just observe, whenever you are passing a time varying current through the coil or inductor, then the time varying magnetic flux will be produced. Time varying magnetic flux will be produced. Okay. So here, say for example, you are having n number of turns you are having. Okay, the total number of turns present in this coil is n. Okay, and in each coil, how much flux is produced? That is nothing but flux generated per every turn. Okay, so if you multiply flux produced for every turn, if you multiply with the total number of turns, from there you will be coming to know the total flux produced by this particular coil or inductor, right? So now for the timing, I am representing the total flux generated by the coil. I am representing as psi. Okay, where psi equal to n into phi. N into phi. So here n is nothing but number of turns. N is nothing but number of turns in that coil, whereas phi is nothing but flux per each turn. Flux per turn. So if you multiply both, from there you are getting the total flux generated by that coil. Okay, coil or inductor both are same. Now, so here whatever the total flux is there, okay, how much flux that can be generated by the coil, that is purely based on how much current that is flowing through that particular coil or inductor, right? So that means psi is proportional to I. Psi is proportional to I. Okay, so here this proportionality, if you want to remove, we can use one proportionality constant. So here we will use that proportionality constant as inductance L. So psi equal to L into I. Psi equal to L into I. Okay, so this is the Ohm's law with respect to inductor. With respect to resistor, Ohm's law is what? V equal to R into I. Okay, similarly with respect to inductor, psi equal to L into I. The amount of flux, total flux produced is proportional to the amount of time varying current that is flowing through that particular coil. Okay, so psi equal to L into I. Once if you got the total flux produced in that particular coil, with the help of that, now we can calculate the voltage, right? So voltage across the coil, voltage across the inductor, V, or you can, if you want, you can represent VL. So voltage equal to L into d by dt, sorry, voltage equal to whatever the total flux you got. Now if you perform the differentiation with respect to time, so from there you will get the voltage, that is nothing but EMF, both are same. So voltage across inductor is nothing but d psi by dt. The time rate of flux is nothing but voltage. Okay, so now you can substitute in place of psi L into I. L into I. So here L is what? Constant. So we can keep outside the differentiation. Then you are getting di by dt. So voltage across inductor is nothing but L into d by dt. Voltage across inductor is nothing but L into di by dt. Okay. Now, once if you are getting the equation like this, from here, if you do the rearrangement, okay, from there we can find the current flowing through the inductor. Okay. See, this particular equation you can use whenever you know the inductor value and whenever you know the current expression or current value. So from there we can calculate the voltage across that particular inductor. Okay. Similarly, suppose in some question if they have given the voltage across inductor some expression and the inductor value, from there if they are asking how much current flowing through that particular inductor, then from here we will get one more equation. With the help of that equation you can directly calculate the current flowing through that particular inductor. Okay. So from here, okay, just do the rearrangement. So di by dt is equal to, you can write VL by L. Okay, I have kept di by dt one side, then inductance I brought to the other side, so it come into the denominator. Okay, now do the cross multiplication. So di equal to VL by L into dt. Okay, now you can perform integration on both sides. Integral di is equal to integral VL dt divided by L. So here inductor value is what? Constant, we can keep outside. So integral di is nothing but I equal to 1 by L integral VL dt. So that means the current flowing through the inductor is nothing but 1 by L integral VL dt. So in this way, whenever you know the current expression, whenever you know the inductor value, then with the help of this formula, you can calculate voltage across inductor. Okay, similarly, once if you know the voltage across inductor expression, and once if you know the inductor value, with the help of this expression, you can calculate the current flowing through that particular inductor. Okay, so I hope all of you got the clarity regarding the voltage expression and current expression with respect to inductor. Okay, whereas for resistor, V equal to R into I, or I equal to V by R. Whereas here, voltage across inductor is L into d by dt, whereas current flowing through inductor is 1 by L integral VL dt. Okay. Now once if you know the voltage, once if you know the current, now we can calculate power. Power is nothing but the product of voltage and current. Power equal to voltage into current. Okay, since I have labeled voltage across inductor is VL and current flowing through inductor as I. Okay, so accordingly VL into I. Now voltage across inductor, this formula we got L into d by dt. So you can substitute L into d by dt into I. So from here you can write Li into d by dt. Li into d by dt. Okay, so this is power. This is the formula regarding power of the inductor. Okay, once if you got the power, can we calculate energy? Yes, obviously. We have discussed, see, whatever the procedure we have discussed with respect to resistor, similar procedure we are following for inductor, similar procedure we will follow for capacitor as well. Okay, right. So once if you got power, now we can calculate the energy. Okay, so energy stored in the inductor. Okay, so I am representing W suffix L. Okay, W or E you can represent for energy. Here L stands for inductor. Similarly, I will use letter C. C stands for capacitor in some time. Okay, so energy is nothing but integral P dt. Integral P dt. Now you can substitute in place of P this entire formula. This entire formula you can substitute here. L I di by dt. Now the term dt and dt will get cancelled. Now L anyway constant, we can keep outside the integral. Integral I di. Now all of you give a try. I hope most of you might have got like this format while you are studying engineering maths. Okay, while you are studying or while you are learning the concepts regarding integration, right? So can anyone mention, after performing integration of this entire expression, what is the term you are going to get? All of you give a try. It is very simple. All of you give a try. It is very simple. Integral I di is nothing but you will get I square by 2. See, suppose if you are having, okay, I square by 2. Okay, this is the function if you are having. Now if you perform differentiation, what you will get? I square derivative is what? 2i into di. 2 will get cancelled. You are getting I di. Okay, so derivative and integration. Okay, if you are supposed to perform, okay, derivative of one function, from there this particular function you will get. Okay, like that, vice versa. Okay, so from here I am rearranging. Energy stored in the inductor is equal to half Li square. See, regarding resistor, we have told that the power is getting dissipated in the resistor. Okay, or energy is getting dissipated in the resistor. Whereas inductor and capacitor, okay, these two elements are energy. These two elements are storing the energy. Okay, So that's why here I am mentioning whatever the formula you got regarding energy with respect to inductor, that is nothing but the amount of energy that is getting stored by the inductor, right? So if you want, you can write here energy stored in the inductor. Energy stored in the inductor is nothing but half Li square. Half Li square. Okay, I hope regarding the formulas with respect to voltage, current, okay, and then power and then energy with respect to inductor, I hope all of you got the clarity. Now with this understanding, now let us move on to the next passive element, that is capacitor. Capacitor, right? Okay, so here you're having parallel plate capacitor. Okay, so across the capacitor, suppose I am labeling it as the voltage across it is Vc and the current flowing through it is I. Okay, see, with respect to capacitor, when you're having two parallel plates, okay, so here the amount of charge that can be stored by that capacitor, that is purely based on how much voltage that you are supplying, right? If you are giving more voltage, according the more charge can be stored. If you are giving less voltage, accordingly less charge can be stored. So that means here the amount of charge that can be stored, by the capacitor is directly proportional to the voltage applied across that particular capacitor. Okay, so from here, just like the earlier, okay, in order to remove the proportionality constant, in order to remove the proportionality symbol, we will use proportionality constant. In this case, we will use C. C is nothing but capacitance. Okay, so Q equal to C into V. Okay, for the timing I have labeled as V suffix C. If you want normal, you can consider simply V. Okay, Q equal to C into V. Now once if you got the charge, stored by that capacitor, with the help of that, can we calculate current? All of you can mention what is the basic relation between current and charge. What is the formula? Yes, very good. I equal to dq by dt. I equal to dq by dt. Okay, now you can substitute in place of q this entire expression. So C into, d by dt into C into Vc. Okay, here C is what? Constant, we can keep outside the differentiation. Then you are getting dV by dt. So from here we are getting current equal to C into dV by dt. Current equal to C into dV by dt. Now once if you are getting how much current flow through the capacitor, okay, that you can calculate whenever they are giving voltage across capacitor expression, and once if they have given the capacitance value, with the help of this formula you can calculate how much current flowing through the capacitor. Similarly, if they are giving current flowing through the capacitor expression and the capacitor value, with the help of those two, suppose if they are asking to calculate how much voltage developed across the capacitor, can we calculate? Yes, obviously. Just you have to rearrange this particular equation. From there you will be getting voltage across capacitor in terms of current. All of you give a try. See, it is very simple. Just like here we have discussed earlier, voltage expression. Okay, V equal to L into d by dt. Okay, after rearranging, we got what? Current in terms of voltage, right? In a similar way, here also we can do. Similarly, here also we can proceed. Okay, so from here I am writing dVc by dt is equal to, I kept this term one side, dvc by dt. So another side we can write I by c. Okay, now bring dt on the right hand side, dvc is equal to I by c into dt. Now you can perform integration on both sides. Okay, so integral dv is nothing but v. Here capacitor is the constant, so we can keep outside the integration. Integral just one second. Yeah, so c we have kept outside, 1 by c integral I dt. Voltage across capacitor is 1 by c integral I dt. By using this formula, whenever you know the current flowing through the capacitor and whenever you are having capacitance value, with the help of this formula, we can calculate the voltage developed across the capacitor. So in this way, based on the requirement, you can use this formula or you can use this formula accordingly. I equal to c into d by dt, or any one formula you can remember. Say for example, regarding inductor, you can remember this formula easily. Voltage across inductor is L into d by dt. From here, just do simple steps like this based on differentiation, integration, based on mathematics, simple concepts, right? Simple steps you can derive. Even in the exam also you can easily derive. Okay, if you are able to remember, fine. Even if you are forgetting, no issue. But at least one relation you remember. With the help of that, you can derive one more equation, right? Similarly, regarding capacitor, you can remember this formula, I equal to c into d by dt. From here, we can derive voltage across capacitor in terms of current. Okay. So once if you got the voltage and current, with the help of these two, we can calculate power. So the next one is, first let us see regarding power and then energy. Okay. Power equal to V into I. So since I have labeled here V, the voltage across capacitor is Vc and current flowing through the capacitor is I. Okay. So current flowing through the capacitor is C into d by dt. So this one let us substitute here, C into d by dt. So from here we can write capacitance is the constant, C into Vc into dVc by dt. So this is the formula regarding power of the capacitor. Okay, once if you got the power, now all of you give a try, regarding energy stored by the capacitor. Regarding energy stored by the capacitor, all of you give a try. See, energy is nothing but what? Energy stored by the capacitor is nothing but integral p dt. Integral p dt. So regarding power, just now we got this expression, you can substitute here, integral C Vc into dVc by dt into dt. Okay, dt will get cancelled. dt will get cancelled. So from here, C anyway constant, we can keep outside the integral, integral Vc into dVc. Integral Vc into dVc. Okay. Now, see regarding this one, we got similar equation earlier also, right? Integral I di is nothing but I square by 2. In a similar way, integral Vc dVc is nothing but Vc square by 2. Vc square by 2. Okay. So from here we can rearrange half CV square. So this is nothing but energy stored by the capacitor. Energy stored by the capacitor. So WC equal to half CV square. This is the energy stored by the capacitor. So previously we got energy stored by the inductor is half LA square. Similarly, regarding capacitor, the amount of energy stored by the capacitor is nothing but half CV square. Half CV square. Okay, right. See, total we are having 3 passive elements regarding network theory subject. So the first one is resistor, second one is inductor, and third one is capacitor. Okay, regarding resistor, we have told that it is energy dissipating or power dissipating. Okay, whereas inductor and capacitor, they are storing the energy. Okay. Now all of you give a try. This is the MCQ. So obviously one option will be correct. So whatever the knowledge so far you have gained with respect to inductor and capacitor, okay, based on that all of you give a try. Only one option will be correct. Among the given choices, only one option will be correct. All of you give a try. Yeah, any guess? See, it is very simple. Here, whatever we have discussed among the 3 passive elements, 2 passive elements are storing the energy, right? So with respect to inductor, with respect to capacitor, you are having the statements. So you have to identify the correct option. Okay. So just observe, in option A it is mentioned inductor stores energy in the form of magnetic field. Yes, it's true. Similarly, the capacitor stores energy in the form of electric field. Both the statements are correct. See, since this is the network theory subject and it is a basic subject, okay, here we are telling or introducing the terms like voltage and current, but when you are studying EMFT subject, okay, whoever from EC, electrical or IN, you will be studying one more subject, EMFT. So in that particular subject, okay, you will be dealing about the field terms like electric field, magnetic field. Okay, so with respect to there you can correlate. Okay, right. So here option A, option B both are correct. So regarding that you are having in option C. Okay, so here in option C it is mentioned both A and B are correct. Okay, so that's why you have to choose option C. Okay, so here with respect to fields you are having electric field and magnetic field, whereas here in terms of basic electrical quantities you are having voltage and current. Okay, so even you can correlate like that. Here energy stored in the capacitor is nothing but half CV square. Similarly, energy stored by the inductor is nothing but half LA square. Okay, in terms of voltage and current you got, but you will be getting more details when you are learning about the electric field and magnetic field in the introduction chapters of EMFT subject. There you will be coming to know how this is, like how inductor is able to store in the form of magnetic field, and similarly how the capacitor is storing the energy in the form of electric field. Okay, but just I am giving the glimpse, but in detail you will be learning in the EMFT subject. Okay, right. So now all of you give a try. This is a simple question based on the energy stored by the capacitor. So this is the NIT question. All of you give a try. What is the answer you are getting? Okay, that answer here, especially when you are attempting any NIT question, you have especially that particular parameter or quantity. If you are having units, you have to take care about that units. Okay, otherwise your answer according to the calculation your answer may be correct, but according to the given question that may be correct or may not be correct if you are not taking care about the units. Okay, because whenever you are having capacitor, they can ask in the order of normal, that means in the order of farad they can ask, in the order of microfarad they can ask, in the order of nanofarad they can ask, right? That's why we have to strictly follow. Okay, so all of you give it a try. It is a simple question based on the capacitor. I hope all of you can get the correct answer. Yeah, just observe here. Try to understand the given question first, okay, and what the given data and what we are supposed to calculate. Once if you are able to get that much details, after that you can easily apply whatever the basic formulas you have learned, you can apply and you can find the unknown. Okay, so just read the question. Energy stored in a capacitor charged to 10 volts. Okay, that means here 10 volts is what? Voltage value. Okay, is 10 power minus 2 joules. That means energy stored by the capacitor is 10 power minus 2 joules. Okay, now you are supposed to calculate the capacitor value. Okay, right. So energy stored by the capacitor is nothing but half CV square. Just now we have discussed this formula, half CV square, energy stored by the capacitor. Okay, in this question the energy value given 10 power minus 2 joules, 10 power minus 2 joules. Okay, 1 by 2 I am keeping as it is. Capacitor value we have to calculate, so C I am keeping as it is. Now the voltage across capacitor is 10 volts, 10 volts, so 10 square. Now do the rearrangement. Capacitor, okay, I am keeping one side, then 2 will come into the numerator into 10 power minus 2. This 10 square is in the numerator. When you bring here, it will come into the denominator, right? It will come to the denominator. Now this value you can write 10 power 2 you can bring to the numerator, it will become 10 power minus 2. So that means as of now you are getting 10 power minus 2 into 10 power minus 2 is nothing but 10 power minus 4, 10 power minus 4. But here we require in the order of microfarad. But as of now you are getting 10 power minus 4 in the order of 10 power minus 4. But if you want to get in the order of micro, so here the value should be how much? Any guess? 10 power minus 6. Very good. 10 power minus 6. So that means here we can multiply and divide with 100. Okay, I am multiplying and dividing with 100. Then what will happen? Say for example, denominator 100, if you bring to the numerator, it will become 10 power minus 2. So 10 power minus 2 into 10 power minus 4 is nothing but 10 power minus 6. Now 2 into 100 is nothing but 200. So 200 microfarad. Okay, if you want I will write one more step. Okay, 200 into 10 power minus 6 farad. So this one you can write it as 200 microfarad. See, whenever the question is MCQ or MSQ, definitely you will be having, okay, choices from there. Even though suppose you got some value, suppose if that is not there in the given choices, then you will be observing in which order of units they are asking. But for NIT there is no clue at all, because after solving the question ultimately you have to enter the number, right? But in the exam you people may be in hurry mode, because of that you may not be taking care in what order of units they are asking. But especially if you want to get the marks assigned for that question, before attempting or before you are entering the number for NIT question, just observe the units. In the order of which units they are asking, in the order of microfarad or millifarad, nanofarad or normal farad, like that. Okay, so accordingly the answer will vary. Okay, right. So finally the answer for this question is 200. 200 is the correct answer. Okay, all of you give a try. Next question, very interesting question which is asked in GATE. This is a question asked in the engineering service exam. Okay, in the engineering service exam 2002, in the year 2002, in the objective paper they have given this question. See, if you are preparing for the GATE exam, okay, whatever the knowledge you are getting, okay, with the help of that knowledge you can attempt other competitive exams related to your discipline, whatever the BTech discipline you are, either from EC, electrical or IN. So accordingly, whatever the competitive exams, other competitive exams regarding central government or state government, so all of you can attempt those exams also, because once if you are getting regarding GATE, whoever thoroughly preparing, okay, regarding the syllabus wise, okay, with respect to other competitive exams, okay, more or less same, okay, but according to that respective exam you may have to prepare something extra or something you may have to skip. Okay, so accordingly you will be focusing according as per that respective exam, but more or less I can say if you are thoroughly preparing for GATE exam, with the help of that you can easily crack other exams. Okay, yeah, just observe here. In this question you are having the current waveform, you are having the current waveform. Okay, a current I of t as shown in the figure is passed through a capacitor. Okay, now they are asking what? The charge in microcoulombs they are asking, the charge in the order of microcoulomb, okay, acquired by the capacitor up to 5 microseconds they are asking, up to 5 microseconds they are asking. See, just recall the basic formula. What is the relation between current and charge? Here regarding current and charge, I hope all of you are very much familiar. In fact, we have discussed this formula also earlier while we are discussing regarding capacitor. I equal to dq by dt, I equal to dq by dt. Now just observe. See, if they have given charge waveform, suppose if they have given charge waveform, then you will be performing differentiation. From there you can calculate current. But in this question they have given current waveform, they are asking the charge. That means we have to rearrange this equation, right? So just do the cross multiplication, you will be getting dq equal to I into dt, dq equal to I into dt. Now you perform on both sides integration operation you can perform. Integral dq is nothing but integral I dt. So here you will be getting charge q is equal to integral I dt. So this is the equation. So in this way you no need to remember all the formulas, you remember the basic formula. If they are giving, okay, with respect to that formula, if you are able to substitute, then you can proceed. But sometimes if they are giving twist like this, then you can rearrange that particular equation even in the exam time. Okay, of course if you are able to solve good number of questions, then definitely once if you know this formula, from there directly one step you can write. Okay, if you are good at maths, if you are good at, like, you know, differentiation, integration, everything, here since it is a foundation course, I am writing each and every step. But once with the help of this equation, directly you can write this one. Okay, whatever the cross multiplication or whatever the integration, everything you can do in the mind level. Okay, so this is the basic formula regarding current and charge. Once if you do the, like, once if you do some modification, after that you will be getting charge in terms of current like this, right? So here we are supposed to calculate the charge acquired by the capacitor up to 5 microseconds. Up to 5 microseconds we have to calculate. So that means here you can observe, here the x-axis is nothing but time, and here you are having in the order of microseconds. In the order of microseconds you are having, you can observe here the 5 microsecond value is present here. So the corresponding, okay, so here instant you are having 4 ampere. Okay, so you have to consider up to this time instant. Okay, whatever the current waveform you are having, okay, so regarding this particular waveform, we have to perform the integration. Okay, one approach I am giving, but that approach you people can try later, but I am giving the hint how to solve. Say for example, here you can observe, like whatever this formula you got, now just by observing this particular waveform, you can observe that from 0 microsecond to 3 microsecond, okay, how the current waveform, here the current waveform is a straight line, yes or no, current waveform is a straight line, okay, right, and then 3 to 4, you are having the waveform like this, okay, and then 4 to 5, you are having the equation like this, okay. So whenever you are having a straight line, okay, okay, if you know any 2 points on that straight line, with the help of that you can write the standard equation of that particular straight line, right? Suppose if this is a straight line passing through origin, y equal to mx, okay, other than this one, for this straight line or for this straight line, if you want to write the equation, okay, if you know the 2 points like x1 y1 x2 y2, from there you can write, okay, if suppose 2 points are there like x1 y1 x2 y2, okay, then you can write the straight line equation like this, y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. Okay, after that this y1 you can bring to the right hand side, it will become positive. From there you are getting y equal to, here y is nothing but current or y axis parameter, right? So in that way, for every interval like 0 to 3, then 3 to 4, and then 4 to 5, you can find the straight line equation or the current equation. Okay, that current equation you can substitute here, and accordingly you can substitute the limits of that integration and you can solve. Okay, but for the time being I am giving one more approach. Here we are using the term integration, we are using the symbol integration. So do you know the physical significance of integration? Any guess? See, one approach I have given, for every interval you will be find the straight line equation, after that you are substituting the corresponding integral limits, and from there you are calculating. Okay, in that way, that is one approach. In that way, whatever the final answer you are getting, okay, regarding the charge acquired by the capacitor up to 5 microsecond, the same answer you will be going to get by following one more approach, that is the shortcut approach or easy approach, we can say. Any guess? Here integration is nothing but area under the curve. Integration is nothing but area under the curve. So whenever you are having the standard waveforms or standard patterns like triangle, rectangle, square, etc., and you are very much familiar regarding the area formula, okay, so with the help of area formula directly you can calculate the values, okay. But whenever you are not getting standard pattern or standard shape, that time definitely you have to follow regular integration. Okay, I hope all of you are getting the clarity when to apply the normal approach or when to apply the shortcut approach. Okay, so but all of you give a try. Okay, with the help of conventional approach also you people can try, and definitely whatever the final answer or whatever the option that we are going to choose regarding this particular question, with the help of this approach, definitely you will be getting the same answer. Okay, right. So for the time being, I am following this logic. Integration is nothing but area under the curve. You can put the star mark. Integration is nothing but area under the curve. Okay, so here just by observing here, okay, between 0 to 3 you are having the pattern or shape like triangle. Okay, between 3 to 4 you are having one rectangle and then triangle. Okay, and then between 4 to 5 once again you are having one rectangle and then triangle. Okay, so whatever the shapes you are having, for every shape you have to calculate the area. Okay, right. So here I am considering first of all 0 to 3 interval. Okay. So in 0 to 3 interval I am representing as Q1. Okay. So in 0 to 3 microsecond, okay, you are having what? One triangle you are having. One triangle you are having. So area of the triangle formula is nothing but half base into height. Half base into height. Here base is 3 micro and then height is nothing but 5 ampere. 5 ampere. So 3 into 5 is 15. 15 by 2 is nothing but 7.5. So 7.5 microcoulomb. 7.5 microcoulomb. Okay. Similarly, I am considering the interval 3 to 4. I am considering the interval 3 to 4. In this interval 3 to 4, if you observe, you are having one rectangle like this and then you are having one triangle like this. Okay. So we have to consider both the areas. Okay. So regarding rectangle, here length is how much? 1 microcoulomb. Okay. 1 microcoulomb. And length into height. Height you are having 3 units. Okay. Then you are having one triangle, half base into height. Base is same, 1 micro. 1 micro. Right. Height is nothing but 5 minus 3 is 2 units. So here in this case 2 will get cancelled. Okay. 3 plus 1, that is nothing but 4. 4 microcoulomb. Okay. Now similarly we have to analyze in this interval 4 to 5. In this interval 4 to 5. Okay. So in this interval if you observe, once again just like earlier, you are having one rectangle. Okay. And then you are having one triangle. And then you are having one triangle. Once again you can calculate area of each. So that one I am labeling as Q3. So in this interval, once again lengthwise 1 microcoulomb, height wise same 3 units. Then here you are having triangle. Okay. Half base into height. Base is same 1 micro and height in this case 3 to 4, that means 1 unit. 1 unit. So here 3 plus 0.5 is nothing but 3.5 microcoulomb. 3.5 microcoulomb. So here our objective is we have to calculate the charge stored by the capacitor up to 5 microseconds. That means Q1, Q2, Q3, all the 3 we have to add, right? So here charge Q equal to up to 5 microseconds. Okay, that is nothing but Q1 plus Q2 plus Q3. So Q1 we got 7.5 microcoulomb plus Q2 we got 4 microcoulomb and then Q3 we got 3.5 microcoulomb. All of you just add these 3. 7.5 plus 0.5, 8. 8 plus 3, 11. 11 plus 4, 15. 15 microcoulomb. Now just cross check the answer. Cross check the options. Yes, we are having in option D. Okay. So option D is the correct answer. In this way, once if you know integration is nothing but area under the curve, with the help of that basic formula, okay, basic notation, you can easily solve these kind of questions. Once if you don't know that integration is nothing but area under the curve, then definitely you can follow the conventional approach. You will be finding for every straight line, you are finding the straight line equation and then you are considering the respective integral limits and then you are performing the integration. Okay. So I hope it is clear for everyone. Okay. Now Just like in the last class we have discussed with respect to resistors, series connection and parallel connection, right? Similarly, now in this particular session we have discussed two passive elements like inductor and capacitor. With respect to inductors, series connection. Similarly, with respect to capacitors, series connection, what are the formulas that you are going to get? Similarly, with respect to parallel connection also, we will be seeing one by one. Okay. So whenever you are having two elements connected in series, okay, we can add the respective impedances. Say for example, okay, for the time being I am considering two elements are there which are connected in series. Okay, in series we can add the respective impedances. Okay, suppose if you are considering two inductors which are connected in series. Okay, two inductors which are connected in series, then in that case the corresponding impedances, okay, the corresponding impedances of these two elements we can add. Okay, whereas for inductor the impedance is nothing but j omega into L. So here in this case I am considering L equivalent. Similarly, you can substitute on the right hand side j omega L1 plus j omega L2. Now you can take j omega as common in the entire equation. From there you will be getting L equivalent equal to L1 plus L2. So that means whatever the formula you got for resistors in series connection, similar formula you are going to get for inductors. Okay, in series connection with respect to resistors, R1 plus R2 you got. Similarly here L1 plus L2. Okay. Similarly, suppose if there are two capacitors are connected in series. So C1, C2. Here also formula is same, Z equivalent equal to Z1 plus Z2, but here regarding capacitor the impedance is nothing but 1 by j omega c. So that means here you are getting 1 by j omega into C equivalent, which is equal to 1 by j omega C1 plus 1 by j omega C2. So in the earlier case we have considered j omega as common from the numerator. Similarly here you can take j omega as common in the denominator. Okay, then j omega term will get cancelled. From there you will be getting 1 by C equivalent is equal to 1 by C1 plus 1 by C2. 1 by C equivalent equal to 1 by C1 plus 1 by C2. Okay, this is the formula whenever two capacitors are connected in series, or similarly if two or more than two are connected, then like this it will be extended. How many capacitors are there? Accordingly like this term you can extend. Okay, 1 by C equivalent equal to 1 by C1 plus 1 by C2. Like this formula you got for resistors, but there you got for parallel connection, right? 1 by R equivalent equal to 1 by R1 plus 1 by R2. Okay, so in this way whenever inductors are connected in series, the formula is just like similar to the resistors, whereas for capacitors whatever resistors parallel connection formula you got, like that formula or notation you are getting series connection for capacitors. Okay, now with this understanding, now let us move on to the other case with respect to inductor parallel connection, with respect to capacitors parallel connection. So whenever elements are connected in parallel, okay, that time we can add the respective admittances. Admittance is nothing but the reciprocal of impedance. Okay, so from here we can write 1 by Z equivalent is equal to 1 by Z1 plus 1 by Z2. Okay, suppose if you are considering inductors, two inductors are connected in parallel. In that case, j omega L equivalent here 1 by j omega L1 plus 1 by j omega L2. Okay, you can take 1 by j omega as common. From there you will be getting 1 by L equivalent equal to 1 by L1 plus 1 by L2. So this is the formula exactly similar to the resistors parallel connection. 1 by R equivalent equal to 1 by R1 plus 1 by R2. In the similar way you are getting for inductors when they are connected in parallel. Okay. Similarly, if you are considering capacitors, are connected in parallel, okay, that time just observe here. Here impedance of the capacitor is nothing but 1 by j omega c, 1 by j omega c. Okay, but here what we are considering, 1 by impedance, that means 1 by j omega c is nothing but j omega c. Okay, so if you want I will write one step, 1 by j omega c equivalent, okay, 1 by impedance is nothing but 1 by j omega c equivalent, okay, is equal to 1 by Z1 is nothing but 1 by j omega c1 plus 1 by j omega c2. Okay, now this denominator term 1 by something, that means 1 by x is nothing but x, right? So from here we can write j omega c equivalent is equal to j omega into c1 plus j omega into c2. Now you can take j omega as common and you can cancel on both the sides. From there you will be getting c equivalent equal to c1 plus c2. Okay, so I hope just observe these equations. It is very simple. Regarding resistors, if you are remembering series connection, exactly similar formula you are getting for inductors series connection. Okay, similarly regarding resistors parallel connection, whatever the formula you are getting, similar notation you are getting for inductors parallel. Okay, so in this way resistor and inductor there is a similarity. Now coming to the capacitors, whatever the resistors or inductors series connection formula you are having, similar notation you will be getting for capacitors connected in parallel. Okay, similarly whatever the formula you are getting for resistors connected in parallel or inductors connected in parallel, similar notation you are getting for capacitors which are connected in series. See, the reason is very simple. How to remember or how to correlate, it is very simple. Regarding the resistor, impedance is nothing but what? R. Okay. Regarding inductor, impedance is nothing but j omega L. Coming to the capacitor, impedance is nothing but 1 by j omega c. Here this is the twist, that's all. With respect to resistor, impedance is R. With respect to inductor, j omega L. That means R, L, both are in the numerator. But coming to the capacitor, you are getting impedance is 1 by c. 1 by j omega c. That means capacitance you are getting in the denominator. Because of that, these formulas are getting like ulta. That's all. Okay. I hope all of you are getting the clarity how to remember these basic formulas with respect to inductors, with respect to capacitors when they are connected in series connection, and similarly for parallel. Okay. So with this understanding, all of you give a try. So for the timing, I am giving this question as a homework. Okay. For the timing, I am giving this question as a homework. So in this circuit, you are having capacitors. Okay. CC, and then CS. Okay. In this question, you have to calculate the equivalent capacitance between the terminals B and Y. Okay. And anyway, you are having choices. You people can try. And whoever watching this particular session, all of you can try this homework question. Okay. So for the timing, I am not solving this question currently, but I am giving as a homework for everyone. So whatever the answer or whatever the option you feel correct, okay, you people can mention in the comment section. Okay. So for this homework question, whatever the option among 4 choices, whichever option you feel correct after solving the question, you people can mention in the comment section. Okay. So for the timing, I am keeping a suspense because in the last class we have discussed variety of questions based on resistors. with respect to series and parallel. Similar model only, but this is a question with respect to capacitors. Okay, whether you are good at visualization or not, whether you are good at observing whether the capacitor is connected in series connection or parallel connection, whether you are able to observe that basic configurations with respect to series and parallel. Once if you are able to observe that one clearly, and here with respect to capacitor, the observation is one important point. After that, you have to apply the correct formula. With respect to series, the respective formula. Similarly, with respect to parallel, the respective formula. Whether you are able to apply the correct formula or not. So just I want to know these two things. Okay, how much you have understood from these 4 sessions. I want to get to know whoever attempting this question, and see whether you are getting correct answer or not, don't mind. Okay, whatever the answer you feel correct among the given 4 choices, you people can mention in the comment section, right? So we'll discuss regarding this particular question in the next week. Okay, so in the next week we are having the 5th session will be there. Okay, so in that session I will be discussing this question at the beginning. Okay, in fact this is a question asked in the GATE EE 1999 for 1 mark. Okay, all of you give a try. This is an interesting question. That is the reason I am not discussing immediately now. Okay, right. So in this particular session we have discussed with respect to inductor, capacitor, the basic formulas, and then we have discussed with respect to voltage, current relationship, and then we have discussed power and energy. Okay, and then we have discussed some simple questions and example questions based on energy and then current. Okay, and then this series connection, parallel connection, we have discussed the basic formulas, and then the last question I have given as a homework. I hope all of you will give a try, and I am eagerly to see all of your comments regarding in this particular video. I am eagerly want to see your comments. Whatever the answer you are getting, I want to check. Okay, so for the time being I am keeping suspense. Okay, we'll meet you all in the next week. Okay, with one continuation session. So we are having network elements part 5. Okay, so all of you kindly share this valuable information, whatever the foundation course series happening with respect to network theory subject. So in this particular series we are discussing the basic concepts of first chapter only. Okay, so whoever getting good command over the basic concepts of first chapter, definitely you people can easily understand the upcoming chapter concepts and even the advanced subjects as well. Okay, right. So regarding Telegram channel, once again I am giving the update. Whoever not yet joined, so all of you kindly join our Telegram channel. Regarding the link already provided in the description of this particular video. So all these benefits you are going to get. This is a free for everyone. All of you can join. Okay, and similarly the one more update here at our IMS GATE Academy, we are having live online program. Whoever aspiring to get very good rank in the upcoming years 2025 or 2026, right, you people can contact to any of these 2 numbers. Our counselors will discuss. Okay, we'll discuss in detail about regarding live online program, right? So don't miss this golden opportunity. Okay, right. So we'll meet you all in one of the upcoming session. Thank you everyone.